Assalamualaikum and hi everyone. Today we will continue with chapter 2 AC to DC converters or rectifier. Okay, in this chapter we will cover on a single phase uncontrolled and controlled rectifier. But we will start with an uncontrolled rectifiers first. Okay, and then as the output voltage of the rectifier are strongly influenced by the type of the load, so we will discuss the basic operation of the rectifier with resistive load, inductive load, and also with capacitive load. Okay, so what is a rectifier? Do you have any idea? So basically, a rectifier is an electrical device that converts from AC to DC by using a power diode or by controlling the firing angles of thyristor or controllable switches. But we will discuss about an uncontrolled rectifier first. Okay, so the output produced by the rectifier is purely DC or a voltage or current waveform that has a DC component. Okay, so this is the basic circuit and basic block diagram of the rectifier. Okay, so as we can see here, for the circuit, it has an AC source, a diode, and also a resistor. Okay, so again, the rectifier will rectify or will convert from an AC input to a DC form. Okay, the simplest network to examine with a time varying signal appears in figure here, where the ideal model is used. So as you can see here, we only have one diode and one resistor. Okay, so over one full cycle, that means from 0 to t here, okay, one full cycle, the average value or the algebraic sum of the areas above, sum of areas above and areas below the axis is 0. Okay, and it is called a half wave rectifier that will generate a waveform V out here, the waveform. Okay. Okay, now let's look on how the uncontrolled half wave rectifier operates. And we will start for the positive half cycle first. Okay, so during t equal to 0 to t over 2 here. Okay, during the first half cycle, the diode is on and start conducting, which result in the equivalent circuit here. Okay, so when diode is conducting, okay, so current can flow. Okay, current can flow. So we get the output voltage here where V in equal to V out. Okay, as you can see here, V in equal to V out. Okay, next for the negative half cycle or during t over 2 until t here, okay, the diode is in off state or open circuit. Okay, so during open circuit, there's no path for charge or current to flow. Okay, so we will get V out equal to 0 times R, so we will get 0 volt. Okay, so this is the output voltage during the negative half cycle where the V out is 0. Okay, and the DC component or V out of an output voltage is the average value of the half wave rectifier sinusoid here. Okay. Okay, now let's look how the uncontrolled half wave R load operates again, but this time for both cycle. Okay, so when the switch is closed at t equal to 0 here, Okay, the diode become forward bias in the interval of 0 until 0.01. Okay, so the VD or the voltage drop here is 0. Okay, so since diode is conducting, so you will get V out equal to V in. Okay, next at t equal to 0.01 here, okay, the V in becomes negative. Okay, so now the diode becomes reverse bias. Okay, when the diode is become reverse bias, it will be open circuit here. Okay, this one will be open circuit. So current cannot flow. Thus, we will get V out equal to 0 volt. Okay, so I is 0. So voltage also 0 for the output during the negative half cycle. Okay, now let's look at the application of a half wave rectifier. Okay, so it is mostly used in low power application only. For example, we have a low power battery charger circuit, soldering iron circuit, pulse generator circuit, and etc. But why it is used in low power application only? It is because the output is less than the input amplitude. And there's no output during the negative half cycle, as you can see in the figure here. Okay, so half of the power has been wasted and the output is pulse DC, resulting in excessive ripple. So there's a ripple in our load half wave rectifier. Okay, so that's it for the uncontrolled half wave R load. For the next slide, we will continue with RL load and RC load. Okay, so thank you for listening. Bye bye.